Hi guys, this is Puneet and I welcome you to this video. Today's topic is Cardinality and Statistics in SQL Server, and this is part 3 of this video series. And if you haven't watched the previous two parts, I would highly recommend please go ahead and do so, because otherwise directly starting from this part wouldn't be as much helpful until you watch the previous two parts. So please go ahead and do so. So let me move ahead, and before I move ahead, if you are new to this channel guys, please go ahead and subscribe to my channel. There's a subscribe button below this video. Click on that subscribe button. It will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding all my future videos. So let me give you 5 seconds so that you can do that so right away. I'm waiting. Please go ahead. So guys, I hope you have subscribed by now. Let me move ahead. There are some points to remember while watching this video. Please watch this video till the end to gain better clarity of the concepts, and if possible for you, please watch this video twice or as many times as you like until the concept gets clear to you. Perform any exercises in your test and lab environments only. Do not touch any production environment or production databases. And we would like to know your thoughts regarding our videos, so please share your comments, any feedback, any suggestions, any requirements, any day-to-day experiences with SQL Server. Maybe you can let us know about the situations where my content has helped you somewhere in some way. So we eagerly wait for your comments, and we would love to read them. So do post them. Alright, let's move ahead. I have created some playlists for you to watch. Some of the major playlists are SQL Server database design, tables, business continuity, indexing, performance tuning, integration services, and transact SQL. So this video belongs to the performance tuning category, and the reason why I create playlist is because if you want to learn about any particular area, it's better to go through a playlist instead of watching videos randomly on any of the topics. So for example, if you want to learn about the performance tuning concept, what I would recommend is go to the performance tuning playlist and watch all the videos from start till the end to gain more expertise in that area. I have posted more than 213 videos on my channel, and the number of videos are growing at constant pace on a daily basis. And I have a channel page link as well given on the slide, and the links for all these playlists and the channel page link are also available in the video description area of this video, so please check out the video description area. Alright, let's go back to the topic. So today's topic is Cardinality and Statistics in SQL Server, and we are covering part 3 of this video series. And let's go to the notes. Today we will be discussing about how we can analyze these statistics. So this will be today's topic: how you can analyze these statistics in SQL Server. So basically, let's talk about statistics. So if we talk about statistics, they consist of 3 sets of data. So the first item is the header, statistics header, density graph. Third one is the histogram. So let me talk briefly about these items. So first one is the header. It basically contains information about the set of statistics that we are looking at. So a header is the row which contains information about the statistics we are looking at. And second is the density graph, which is a mathematical construct of the selectivity of the columns that make up the statistics. We will show you practically how to view the density graph. Basically, we can say it's a mathematically construct of the selectivity of a single column or multiple columns that make up the statistics. And third data set is the histogram, which is basically a statistical construct that shows how the data is distributed across the actual values within the first column of the statistic. We'll talk more about that later. Alright, so histogram is the most commonly used data set out of these three. So out of these above three statistics, histogram is the most common one that we will use, and it basically shows a sample of data and accounts of the occurrences of these values. The steps are generated from the data in the question, from the random distribution across the data. Now I will cover some of the demos, so please be ready. So in the first demo we will create a test table for statistical analysis. Then we will show you how you can retrieve the statistics using the dbcc show statistics function. And the third practical I will share is we will share the explanation of each of the header, density and histogram practically. Alright, so let's dive into demos. So this is demo 1. and this is demo 2 and this is demo 3. So 3 demos we will be covering. So let's get ready. So let's go through the first demo. Let me trigger the SQL Server. So SQL Server is up. Let's connect to the default instance of SQL Server database, and let's select the My AdventureWorks database. For you it may be named AdventureWorks. I have renamed my database to My AdventureWorks. That's the only difference. Let's trigger a new query against this database. So you may write the code along with me. So let me save this query as statistical analysis. Alright, so you can write this query along with me. So first of all, we are checking whether there is a table with the name test1. If it exists, please drop the table. Spell it correctly. Drop table if exists, dbo.test1 is the table we are looking for, and then press the go statement. So let's execute it side by side. So if any table with the table name test1 exists, this will get dropped when I run this statement. Now let's create a table with the name dbo.test1. I'm again creating this table. Alright, let's define the structure of this table. I'm taking 2 columns. First one is C1 column. It will be integer type, and there is a C2 column which will be integer type as well, but this will be an identity column. For identity columns we do not have to supply any values. So this is the table structure I want to create. So let's quickly go ahead and create it. So table structure is created. Now let's move on and insert some data into this table. So let's do insert into the table dbo.test1. Alright, and let's insert into column C1. I can take that in single row as well. So let's insert value into the C1 column. So values will be, I'm just putting 1 inside this, 1 as the value inside this table. So let's execute this. After that we can check the table as well. So if we do select star from dbo.test1, what we will see the one row with value 1, and there is an identity column which automatically took the C2 is the identity column, so it automatically takes the value 1, and this is the value we inserted in the C1 column. So I've checked the data. Now what we are doing is, let's create a temporary table and select 10,000 rows into it. So this will be identity rows, and it will be integer type starting from 1 and incrementing by 1. Alright, and we are taking the column name as sen, and in order to generate this 10,000 values I need to iterate through one of the tables. So let me take one of the tables. We will not be using the actual values from the table, but yeah, we are just iterating through it. So let's take person.business entity. It has more than 10,000 rows. So let's take person.business entity. So, and after as n, I need to keep these values into, I'm generating this value into a temporary table nums. So let's execute this statement. So a nums temporary table is generated. We can select the value from the nums table. So let's select what's inside there. So we have 10,000 separate values, right? So yeah, 10,000 values are generated. Now what we will do, we will insert into the db.test1 table, again using the C1 column for insertion. And what we are doing is, we are selecting 2 from hash nums. So what this statement will do, if I just select this statement, it will generate 10,000 2 values, 10,000 rows of 2 values. Alright, so this is how you can see all the rows are having 2 values. So let's insert these 10,000 rows with the value 2 into the test1 table C1 column. So now our table has one row with the value 1. So if I take a look at the dbo.test1, this table has a one row with value 1 and rest of the 10,000 rows as value 2. Alright, and now we don't need the table nums, so I can drop it here. So let's drop the temporary table nums as it is no longer required. Let's execute the statement. So table is dropped. In the end, I am creating a non-clustered index. This is not a clustered one. So I'm creating a non-clustered index, and let's name it first index. and we are creating it on DBO test1 C1 column. Alright. So this final command will create a non-cluster index on the table. When that happens, SQL Server automatically creates statistics. So earlier we had also discussed that whenever we create an index on a column, SQL Server automatically creates statistics based on the index key. And we can retrieve the statistics for the non-cluster index as well by executing the dbcc show statistics function. So let's execute this statement to generate the index as well as statistics. We can check the statistics of the index by using the dbcc show statistics functions. So this function can be used. Here I need to supply the table name for which I want the statistics, and I need to specify the index which I have created to check the statistics. So if I run this query, I will get the result below. So what I got is, I got 3 rows when I run the dbcc show statistics on the first index that I have created on the test1 C1 column. So let's talk about the data we have got. So we get 3 distinct result set, right? So 1, 2 and 3. This is the first one, this is the second one, this is the third one. Alright. And we got 3 distinct result sets from the show statistics command that we just ran. And so what these are header. So this one is header, and this one is the density graph, and the third one is the histogram. So this is the histogram. Alright, and let's step through each of these in little detail and discuss what each means. So we are on right now, if I talk about, we are on demo 3. Alright, so we are done with demo 1, we are done with demo 2. We have run the dbcc show statistics command, and right now I'm practically explaining what is header, density and histogram. So the row we got is we received here is the first data set is the header. So let's talk about it. So the header contains information about the statistics as we read earlier, right? So the header contains information about the statistics, and some of the data is quite straightforward here, such as the name, which is the first index, right? And the second thing is updated value, where the data is straightforward. So this index was last updated on this particular time, 6:36 is the time when the index statistics on the index were created. Alright. Now the rest is descriptive about the statistics. So let's start with the rows column. So rows represents the number of rows in the table. So we have 10,001 rows in the table at the time statistics were collected. So this number represents the number of rows in the table at the time when the statistics were collected or created or updated. Alright. And next is the rows sampled column, and this column shows how many of the rows were sampled to create the statistics. So in our case, all the rows were sampled to create the statistics, nothing was left. So all the rows were sampled. The header list show many steps are in the histogram. Here we only have 2. Okay, so this indicates the steps in the histogram. So in the histogram we have 2 steps, 1 and 2. So that row is particularly referring to that we have 2 steps in the histogram. Now let's talk about density. This density is shown as the average key length for the index. So density here is 0. The rest of the columns are just describing the state of the statistics in question and are dependent upon the other settings, which we will cover later on. Alright, so we got other information as well. Unfiltered rows are 10,001 because we have not used any filters. Alright, let's move on, and now let's talk about density in little bit detail. So this is the next data set visible in the middle, right? It is density. Alright, so when creating an execution plan, basically the optimizer analyzes the statistics of the column. So before creating the execution plan, the optimizer analyzes the statistics of the column, right, used in join, having and where clauses. So whatever columns are used in the join, having and where clauses, optimizer analyzes the statistics of those columns. So the first point is, when creating an execution plan, the optimizer analyzes the statistics of the columns used in join, having and where clauses. So whatever columns are used in the join, having and where clauses, the optimizer analyzes the statistics for those columns. Now, a column with a unique index will have a very high selectivity, since it limits the number of matching rows to 1. So basically what we are trying to say, that a filter with high selectivity limits the rows that will be retrieved from the table, and basically optimizer chooses that row, or selects that row with the higher selectivity, select that column with the higher selectivity, as it limits the number of rows that will be returned. On the other hand, if we talk about filters with low selectivity, will return larger result, whereas a filter with low selectivity will return in larger result, and the filter with high selectivity will result in smaller result from the table. And basically if we talk about filter with low selectivity, so a filter with low selectivity can make a non-clustered index ineffective or useless. So if our filter is having a low selectivity, or if it is returning a large set of results, it makes the non-clustered index ineffective. So navigating through a non-clustered index to the base table for a large result set is less efficient than simply scanning the clustered index or the base table in case of heap. So let me take you through that. So basically we are talking about the filters with low selectivity and filters with high selectivity. So a filter with low selectivity will yield the larger result set, whereas the filter with high selectivity will result in smaller result set. So a filter with low selectivity can make a non-cluster index effective, where we have a large result set. A filter with low selectivity will have a large result set, and that can make non-cluster index ineffective, because navigating through a non-cluster index to the base table for a larger result set is less efficient. Alright, so in case of non-cluster indexes, we basically navigate between index and the base table. So if the result set is large, we have to continuously navigate between the index and the base table, which is very less efficient. Compared to that, if we simply scan a cluster index, that would be very much useful. Or if we just have a heap without the cluster index, we can directly scan the table as well. In those cases where the large number of results set will be returned, it's better to scan a table or better to scan a cluster index rather than to seek the non-cluster index, because we have to continuously navigate between the non-cluster index and the base table. Alright, so statistics basically track the selectivity of a column in the form of density ratio. So let me write that as well. Statistics track the selectivity of a column in the form of a density ratio. So we have rows for density as well, we will talk about them. So it has calculated the density of column 1, which is C1, average length of 4, and the density of 0.5. We will talk about that soon, so give us few minutes. Alright, so we are talking about the statistics. Basically, statistics track the selectivity of the column in the form of a density ratio. In our case, the ratio is 0.5. Alright. So basically, if we talk, there are two calculations. One for a single column set of statistics like what we are dealing with here. So here we have calculated the statistics on only a single column on which the first index was defined. So we are dealing with the single column statistics here. So there are two type of calculations, one for a single column set and the rest one is for the multiple column set. So we talk about second for compound statistics. So second calculation is for compound statistics consisting of more than one column. Alright, and we will talk about compound statistics later where more than one columns are involved. Now let me discuss a little bit about the calculation. So how the density is calculated. Density is equal to 1 divided by number of distinct values for a column. So in our case, how many distinct values are there? There is only two distinct values. So in our case, it is 1 divided by 2. So the net result is 0.5. Alright. So this is the density which has calculated because our result set has two distinct values which are given over here, right? So 1 divided by 2 is 0.5. Alright. So this is how the density is calculated. And let's talk more about density. So if we talk about density, density will always come out as a number somewhere between 0 and 1. So it should always be a number between 0 and 1. And if we talk about density, the lower the density, the more suitable it is for the use as an index key. So the column which has less density or the lower density, it is more suitable for use as an index key. And if we want to run a command to check out the density ourselves, what we can do is we can run this command. Although the density is calculated here, but here if we want to calculate it manually, what we can do, we can run a select command where we can do select 1.0 divided by, we can take count of distinct values of C1 and we want to calculate it from dbo.test1. So that will gives us the density, right? So if I execute it, this is the density, 0.5 is the density, right? We can get it via this function as well, dbcc show statistics. So the density of C1 column is 0.5. And the density is used to estimate the number of rows when the histogram won't work. So in case this histogram won't work, the density is basically used. So the density is basically used to estimate the number of rows when the histogram does not work. The calculation is basically simple in this case. Multiply the density value times the number of rows to get an estimate on average number of rows for any given distinct values within the table. So let's talk about this. Let me write this down. The density sometimes can be used to estimate the number of rows when the so we were talking about density. Density sometimes can be used to estimate the number of rows when the histogram doesn't work. So the calculation here is simple, and how the calculation is done, we multiply the density value with the number of rows to get an estimate on the average number of rows. So here if we take a look at stats, it has taken an average length of 4. This is how it has calculated this value. So basically this density value can be used to calculate the average number of rows to calculate the estimate on the average number of rows for any given distinct value within the table. So density sometimes can be used to estimate the number of rows when the histogram doesn't work. And how it works, the calculation is done. Basically, we multiply the density value with the number of rows to get an estimate on the average number of rows for any given distinct value within the tables. Alright, let's finally talk about the histogram here. So histogram is the third set of data here, and it is the most used piece of data in the statistics is the histogram. So this is the most important piece of data or in the statistics which is histogram, and it is the third data set, so we covered it last, but it is the most important to understand, and it consists of only 5 columns here and up to 200 rows or steps. In our case only 2 rows are there, but there can be up to 200 rows or steps as well. So each row is called a step in the histogram. And let's talk about column in here. So first column is the range high key. So here we see 1 as the value. So it basically talks about the top value in each range. So the first range, the top value is 1. For the second range, the top value is 2. There may or may not be values within the range. So there could be a range where there may not be any values. Here we have values for both the range. But there may be ranges where we do not have any values for the range high key. And this value will be the actual value from the data in the column. If it's a number column, like in our case integer in this example, it will be a number. If it's a string, as we will show in some later examples as well, it will have some value within the column shown as a string. So in the cases of string columns, it will contain some string. Alright. For example, London from a city column can be seen here in the range high key if our column is a string on which the statistics are calculated. But in our case it's an integer column, so we are seeing two ranges. The highest value for the first range is 1 and the highest value for the range 2 is 2. Now the second column is the EQ rows, this one. Let's take it as second column. So EQ rows represents the number of rows within the range. So within this range we have only one row, and within this range we have 10,000 rows. So EQ rows represents the number of rows within the range at the point when the statistics were updated. So these are the calculations at the time when the statistics were updated or created that match the range high key value. Alright, so let's move on to third column, which is range rows, which basically represents the number of rows between the previous top value and the current top value. So there are 0 rows between the previous top value and the current top value. Same for this row as well. There are 0 number of rows between the previous top value and the current top value. So it basically represents the range of rows or count of rows within that boundary, right? Boundary points basically. Now let's talk about next column, which is distinct range rows. It represents the number of distinct values within the range. So right now there are no distinct values within this range. Same for second range as well. There are no distinct values. If all of the values are unique, then the range rows and distinct range rows will be equal. If all the values are unique, both these values will be same within the range rows and the distinct range rows. Alright, and let's talk about the average range rows. So this is basically the number of rows equal to any potential key values within the range. So in this range we have only one key value, and in second range also we have only one key value. The optimizer will have a value, let's say 1 from our example. It will then look at the histogram. The optimizer will have a value, let's say 1 in our example. It will then take a look at histogram to determine the estimated number of rows. Alright, since the value 1 is the range high key, so in our case the value 1 is the range high key for the first range or step, it knows that EQ rows has a value of 1 and therefore does not have to do any other calculations. So when these two values are equal, the optimizer does not have to do any other calculations. As our example data set only has a pair of values 1 and 2, we have a single row with value 1 and 10,000 rows with value 2. We only have two steps to examine. Let's take another look at some other set of statistics. All right. So in this case, let's use some other table, not the test run table. So let's take DBCC statistics for show statistics. Let's take the statistics for another table, which will be sales order detail table. I'm taking from the AdventureWorks database, and my case it's my AdventureWorks. In your case, it should be AdventureWorks. And there is an index defined on this table, which is index ix sales order detail underscore product ID is the index defined on this table. So I'm taking that index, the product ID. Alright, let's take this index and take the statistics of this index, which is defined on so particular column on this table, sales or sales order detail. So it will show us the column as well on which the index is defined. So let's get the statistics for this command. So this index is defined on multiple columns, so it's a multi-column index, right? So we have this densities available for multiple columns. So let's take a look at here in detail. Now we have run show statistics for sales order detail table, and we have passed in the index. So basically this table, this function takes the indexes as the argument. So in our case, I passed on the argument as index, which is defined on the sales order header table. Now let's take a look at histogram for this particular index. So this is the histogram, which has many set of rows over here. So this is basically, if we just take a look at this range, this is the subset of histogram. It has many rows if we scroll down. Alright. Now let's assume we have a value 827. So let's take a value 827, which is here. It's not showing my 827 value. Okay, let's take 827 value. Let's see what it shows. 827 value is otherwise not present in the table. It has up to 826, then 827 is missing. So let's take value 827, and if we take a look at range high key values, right? So if we take a look at this column, range high key values, the closest one above our value is, so above 827 we have a value 831. Alright, so we have taken 827 as an example value, and if we take a look at range high key column, the closest one above our value is 831. So that is fine, because the lower one below that is 826, the higher one above 827 is 831. If we then look at the average range rows, so what are the average range rows here is 36.6, 4 times 6, 7. Now if the optimizer were creating an execution plan, now let's assume an optimizer is creating an execution plan, it would estimate that there would be 36.66667 rows that match the value 827. Alright, so this is how it estimates that. I've given by taking an example of value 827. So how optimizer estimate the count of rows. So it takes if that particular high range value is not present, then optimizer takes the next value, the next most highest value, which is 831 in our case, and it then takes a look at the average range rows to get an estimate how many rows are present for that particular value. So for 827 it will take 36.66 as the average number of rows for that particular value. So guys, this topic is done, and I've just shown you how you can analyze the statistics. So I hope you liked this video and you got the detail. And you can go through this video once, and if you want to gain better clarity, please go through it once. So here in this video we have defined how to analyze the statistics. Basically we have discussed three data sets, which are header, the density graph, and the histogram. We have shown you practically how to check these three data sets, alright, by giving you some of the examples. The most important data set in our case is the histogram, which is the last data set in our case. So this is the one which is the last data set, and I've shown you how the optimizer make an estimate on the row count based upon the range high key values from the histogram. So I've given you just an example. So I hope you like this video. Let's go back to the presentation slide. And let's go back to notes quickly. So in our next video, what we will cover cardinality, guys. So I would suggest you to stay in tune. If you have not subscribed to the channel, please go ahead and do so. That is pretty much essential. My next video will be releasing soon, and I will cover cardinality as the topic with some practical examples as well. So I hope you will find the next video useful as well. And after cardinality, we will cover the statistics on a multi-column index. So in next video, we will try to cover the cardinality topic. Let's come back to slides. So today we have covered how to analyze the statistics, and this is the part 3 of this video series, cardinality and statistics in SQL Server. In case you need the PDF copy of the notes, these will be paid. INR 25 per page is the charge. And in case you need the PDF notes, just send me the request via the email. Just mention the topic of the video in your email for which you want the PDF notes. And upon getting your email, I will send you the payment link, and upon making payment you can download the notes in case you have not handwritten the notes while I was writing. So yeah, in case you need the notes, please do send me an email. And we are done with this video. And guys, if you are new to this channel, please go ahead and subscribe immediately. There's a subscribe button below this video. Click on that subscribe button. It will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding all my future videos. And also please, if you really like this video, please click on the like button below this video. And also do share in your comments, suggestions, feedback, reviews, any requirements, any day-to-day experiences with SQL Server, any situations where my content has helped you in some way somewhere. And do post us your comments, guys. We eagerly wait for them and would love to read them. So do post in your comments. And also guys, if you have a good network of friends, please share my videos with your friends, and in case they are working in SQL Server domain. Also ask them to join my channel or subscribe to my channel. There's a subscribe button below my video, and you can ask them to subscribe to my channel. I need this help from your end. I thank you so much for your time on this video today, guys, and you have a wonderful day ahead. Thank you.